Elon Musk's vision for a Martian colony presents a daunting challenge, requiring a level of coordination and resources unparalleled in human history. The sheer scale of the project, comparable to building a global metropolis, launching the Apollo missions, and establishing a complex space station all simultaneously, highlights the immense undertaking. This ambition necessitates a profound shift in both engineering capabilities and global cooperation. The task demands a unique partnership between established space agencies like NASA and innovative private companies such as SpaceX. This monumental endeavor requires the amalgamation of existing knowledge and the development of entirely new technologies to enable the complex logistics of transporting people and resources across vast distances in harsh extraterrestrial environments. The combined efforts of both organizations will dictate the likelihood of success in this monumental project. The human desire to explore and potentially settle other planets is a fundamental part of our existence. This inherent drive has now, for the first time in our species' history, matched with the necessary technology. This unique opportunity presents a new responsibility, but also a potential for a new era of human expansion. The window of possibility to venture beyond Earth is narrow and fleeting, demanding swift action and careful consideration of the risks involved. This historic moment necessitates swift and decisive action to capitalize on the technological breakthroughs that have enabled this unprecedented capability. The rapid advancement of space travel technologies now creates a crucial window of opportunity for human expansion beyond Earth. The current generation bears the responsibility of leveraging these developments, with the ultimate potential for lasting impact on the human race. SpaceX's Starship, designed for deep space missions, addresses a crucial problem in space travel: the enormous power needed to transport significant mass into space. Its super heavy booster boasts far greater thrust than previous rockets like the Saturn V, enabling the transport of much larger payloads. This increase in capacity is essential for a potential Mars mission, carrying the substantial amount of equipment and supplies needed for a sustained human presence. This capability is paramount to ensuring the survival and potential success of a Martian colony. The need for more powerful rockets is highlighted by the immense quantities of material required. Starship's design represents a significant leap forward in rocket technology, a necessary step for large-scale space exploration and settlement efforts. This advancement, along with ongoing engine development, is key to achieving the ambitious goals of Mars colonization. Musk's Mars colonization plan hinges on a massive production ramp-up of Starship vehicles. This ambitious goal necessitates a significant increase in manufacturing capabilities, surpassing even the output of the Apollo program. The sheer volume of materials needed for a self-sustaining Martian colony demands an unprecedented production rate. This high volume is necessary to transport the immense resources and infrastructure required. SpaceX must dramatically increase its manufacturing capacity and efficiency to achieve the necessary production rate. The logistical scale of moving that much material requires a remarkable feat of engineering and organizational capability. Success depends on the ability to efficiently assemble and deploy a massive fleet of starships. Musk's vision for Mars necessitates advanced technological solutions beyond simple transportation. Critical components include sophisticated life support systems capable of sustaining human life in the harsh Martian environment. This aspect demands innovative engineering and a focus on resource management. The ability to create self-sufficient habitats in an alien environment will be vital. Developing reliable and efficient life support systems is essential for the survival of any Martian colonist. Success hinges on addressing the unique challenges of creating sustainable environments in the hostile conditions of Mars. The ability to provide a habitable atmosphere and critical resources for long-term survival will be a key determinant of the success of a Martian colony. This represents a critical challenge in space exploration. While Starship offers significant advancements in rocket technology, its reliance on chemical propulsion presents limitations. To truly achieve the ambitious goal of Mars colonization, a significant leap beyond current capabilities is required. Nuclear propulsion, a technology NASA has explored, could unlock the potential for faster transit times and greater payload capacity, crucial for the sustainability of a Martian settlement. The limitations of chemical propulsion highlight the need for alternative solutions to facilitate efficient, and safe journeys between Earth and Mars. Nuclear thermal propulsion, a potential solution, is crucial for achieving the ambitious goal of faster and more capable deep space travel and supporting a sustained Martian presence. The potential for nuclear propulsion to dramatically increase the efficiency and reach of future space travel is a key factor in achieving Mars colonization. The successful establishment of a self-sustaining Martian colony hinges on meticulous planning and preparation beyond simply developing the spacecraft. Comprehensive research and simulation, like NASA's Mars mission simulators, are critical for understanding the unique challenges of long-duration space missions. Testing in simulated environments is essential to evaluating and mitigating potential issues. The crucial need for rigorous testing in controlled environments before a manned mission underscores the significance of comprehensive preparation. The detailed planning and execution of this preliminary research are essential for ensuring both the safety and the long-term success of a Martian settlement. NASA's ongoing research and simulations underscore the importance of careful planning to avoid potential dangers and support a successful transition to a new planetary environment. The success of Mars colonization hinges on the symbiotic relationship between SpaceX's technological prowess and NASA's extensive experience in space exploration, resource management, and long-duration missions. Both organizations' combined expertise is vital. This collaboration is crucial for effectively managing the complexities of establishing a self-sufficient colony in the harsh Martian environment. The partnership leverages the strengths of both organizations to address the multifaceted challenges of establishing a sustainable human presence beyond Earth. This crucial collaboration addresses the diverse expertise needed for such an intricate task, from the engineering marvels required for transportation to the critical logistical considerations for supporting a large, isolated population. The success of Musk's ambitious plan hinges on the ability of both organizations to collaborate effectively and seamlessly. The mission to Mars. Can SpaceX put the U.S. flag on the red planet? SpaceX has long set its sights on Mars and has made the bold promise that they will land humans on Mars in 2029, which will eventually pave the path for Chief Executive Officer Elon Musk's plans for Mars colonization by 2050. Their confidence in their plans to set foot on Mars has only seemed to grow with their recent support for Trump's promise to put the U.S. flag on Mars. SpaceX has outlined a timeline for this goal, the first step being to send unmanned starships to Mars by 2026. Should this attempt be successful, SpaceX claims that they can send the first crewed mission to Mars in 2029 using the Starship spacecraft that is capable of holding both crew and equipment in a super heavy rocket. Together, they claim, these two technologies will create a sustainable and reusable mode of transport to and from Mars. According to SpaceX, a trip from Earth to Mars using the technology in their Starship crafts would take around 6 months. The ship is designed to use local resources on Mars to refuel, then to return directly to Earth. These claims certainly ignite the imagination of avid science fiction fans. But are these ambitious plans feasible? According to UCSB's Professor Bassem Bamier, who specializes in the control and dynamic systems that relate directly to the technology used in spaceflight, the engineering community regard Musk's claims with skepticism. It is true that SpaceX has accomplished extraordinary things. One of their biggest innovations is the relanding of booster rockets, Bamier explained. That's what has made them able to send so many satellites into orbit at lower cost. Indeed, SpaceX's Operation Starlink successfully launched thousands of satellites around the world, providing internet to areas that have poor or no connection, and is an example of the impact SpaceX's forward-thinking. A lack of novel propulsion technologies plants doubts as to whether SpaceX will meet their deadline. However, in the past, it was SpaceX's persistence that is a key ingredient to their success, more so than new technologies, according to Bamier. Unlike federally funded companies like NASA, SpaceX has the money and resources for more trial and error, which, while less rigorous, has proven to get results faster. SpaceX's success with relanding rockets, for example, came from a lot of failed experimentation. According to Bamier, they blew up a lot of rockets to start doing this. Such a methodology is unique to SpaceX, and Bamier speculates it could be since A lot of people came from the software industry as opposed to the traditional aerospace industry, where safety is a very crucial requirement. There's a lot of trial and error. In addition to resources and persistence, the reason SpaceX is able to confidently back the plan to put the US flag on Mars lies in the uniqueness of their ambition among companies in the space industry to put humans on the planet. Other companies have refrained from such a goal due to the overwhelming resource demands of sending humans to planets, as opposed to simply sending robotic equipment to take data. It's one thing sending rockets to Mars, but sending humans to Mars and back is an astronomical task with far more demands, according to Bamier, namely sustaining human astronauts on these ships. And the size of these ships need to be significantly bigger than the robotic missions already sent to Mars. Life support needs to last much longer, and you need a spaceship capable of coming back, which has not been done in any robotic missions before. Bamier reasons that adding humans into the equation is not all that practical, as the extra advantage is very questionable, but the costs are astronomically higher. Scientifically, it doesn't make a lot of sense.